Welcome to the Design30 Podcast. My name is Jason Bilyeu, and in this podcast, I provide design strategies and tools to improve creativity, innovation, and overall design confidence. Today, we will be talking about ideas. And ideas are essentially the backbone of our economy. They're what drive innovation and improve our lives. They also create controversies. They can change our culture and basically make life interesting and what keep it ever changing and ever evolving. But what actually is an idea, and how do you create environments to develop more ideas? And how do you develop good ideas, which is obviously what we are all striving to do. In this episode, I'm going to be using the example of Bell Laboratories to help drive this idea and the points around how to develop good ideas, how to drive those home, and how to, essentially just give some examples of how that's been done in the past by one of the most successful companies and successful research and development departments of that company. So we will discuss how time, collaboration, good questions, and dedication can lead to innovative and creative ideas. But first, make sure to rate the podcast and subscribe to the Design30 YouTube. You can follow Design30 on Instagram and Twitter. The handle is @LearnDesign30. And then finally, please become, if you're interested, a free subscriber to the Design30 Substack, where I release an article or one of my writings 1 to 2 times per month. And if you would like to support the podcast in any way, you can actually become a paid subscriber to the Design30 Substack. So today we are talking again about ideas. And to frame the conversation, I'm going to be using the example of Bell Labs, which is one of the most successful and well-known research and development laboratories in the United States and probably in the entire world. The amount of inventions and innovations that they came up with is pretty incredible. So just to frame this to start, I'm going to read a little bit from the back of the book that I'll be quoting. And the name of this book is The Idea Factory: Bell Labs and the Great Age of American Innovation by John Gertner. So on the back of the book, they do a really good job of just kind of setting the scene for what Bell Labs is and what it's known for. From its beginnings in the 1920s until its demise in the 1980s, Bell Labs, the official research and development wing of AT&T, was the biggest and arguably the best laboratory for new ideas in the world. From transistors and fiber optics to lasers and cellular telephony, it's hard to find any aspect of modern life that hasn't been touched by Bell Labs. And perhaps you've never heard of Bell Labs. You might be thinking, I have no idea what that is. I've heard of AT&T, of course, but didn't know that they had their own research and development lab. But odds are, it's actually, if you're living today, guaranteed that you've interacted with technology that was either thought of, new ideas were developed, the technology was developed, or it was innovated by Bell Labs. And just a few of their probably biggest inventions or most well-known inventions are data networking, the transistor, which is what all of our computing power is based off of, cellular phone technology, solar cells, the laser, digital transmission and switching, communication satellites, touch-tone telephones, Unix operating system and the C programming language, digital signal processors, They also developed early on electrical sound recording, quality control theories. They developed, designed, engineered, and actually helped install the transatlantic telephone service. They developed wearable electronic hearing aids, and they were also responsible for detecting the cosmic microwave background radiation that was proof of the Big Bang. So whether it was science, maybe it was the phone that you called your grandparents on this morning, or even just the computer, smartphone, the iPad that you're using right now, the processing power behind it, it all leads back to this company, AT&T, which now you probably know them as a cell phone company, but in the early 1900s and kind of throughout the 1900s, they're actually one of the largest, if not the largest company. I don't know if they were the largest, but one of the largest companies in the world. And in the United States, they essentially held a monopoly over all of the telephone services in the United States. They had essentially this Bell Labs laboratory, which came up with a lot of new ideas and was constantly developing new technology. And the new products they developed were manufactured by Western Electric, which actually produced a lot of the equipment that the telephone system was ran on. And then AT&T was the kind of overarching telephone company at the time. So massive company, essentially a monopoly. There's reasons that I won't get into in this podcast of why the government allowed them to continue operating. Some of those you can imagine are related to benefits they provided to the military, as well as just overall benefits to society, providing this ability to communicate over long distances. Overall, AT&T and their research and development laboratory, known as Bell Labs, were responsible for developing an incredible amount of new ideas and taking these new ideas into actual production, actual innovative products. So coming back to the core of this episode, what is an idea? And I'm sure there's a formal definition that you can look up, but I think of ideas as hypotheses, as questions. They can be a simple connection between two ideas or topics that usually aren't seen as being connected. In the end, it's really a starting point. It's a starting point for a new investigation, a new test, a new product, a new innovation, maybe a new improvement on an existing product. An idea is, at its core, I think, a starting point. In all innovations, inventions, multi-billion-dollar companies start with an idea. Yet we all have ideas, and very few of us create new innovative technologies, and very few of us are multi-billion-dollar owners of multi-billion-dollar companies. So what does it actually take to develop a good idea? And we can all come up with bad ideas all day long, but what does it take to actually develop a good idea? Well, number one, as I mentioned at the beginning of the podcast, it takes time. You need time to think and time to hypothesize, time to test, and you need a space to actually create and build and try out new ideas and to fail and to think through why you fail, to come up with a new hypothesis and test that. And you need time for discussions. There needs to be arguments and disagreements and even competition. Obviously, healthy competition. You don't need to, or hopefully you're not hoarding ideas or preventing other people from having the capabilities, the ideas, the input they need to innovate and develop creative new products. You need time to brainstorm, and you need time to be bored. I think that's something a lot of companies don't realize, or at least it's really difficult to actually implement in a company setting, is time to let whoever your creative thinkers are, your product developers, your engineers, they need some time to be bored, because that's when people start thinking of new ideas. They think of ways to become more efficient. Maybe there's something that they have to do every day, and it just takes way more time than it should. But you don't ever have time to actually solve it. You don't have time to come up with a new process to replace it because you're so busy. And in a 40-hour week, companies want to keep you busy. That's how they get the most production out of you. Or at least that's how a lot of companies believe they get the most production out of you. But as can be seen in the developments of Bell Laboratories and in a lot of other companies, giving people some time to be bored and have space and time to be creative and think of crazy new ideas and bring those up to their coworkers and have brainstorm sessions, those can actually pay a lot of dividends in the long term. But I'm getting a little bit ahead of myself with that. So going back to this idea of time, I want to read the first excerpt from this book, which again is called The Idea Factory by John Gertner. So here the author is quoting someone from the Bell Labs, and he says, of its output, Arnold would later say of his group, inventions are a valuable part, but invention is not to be scheduled nor coerced. The point of this kind of experimentation was to provide a free environment for the operation of genius. His point was that genius would undoubtedly improve the company's operation, just as ordinary engineering could. But genius was not predictable. You had to give it room to assert itself. So I think the primary point here, again, goes back to time. But in this context, he's wanting to give time to these people he's calling the geniuses of the company. So the idea behind the Bell Labs is they have some of the world's smartest people in this building, and they're not all working on one project. It's not just one engineering project to develop a new, a transatlantic cable. Although that's part of it sometimes, what they're really doing is looking at some of the more fundamental technologies, and they're getting these incredibly smart people, putting them in a space, and they give them some direction, but for the most part, they're wanting to give them a free environment to, as they say in the book, let their genius operate. The goal was to provide a free environment for the operation of genius. So I think a big part of this laboratory success comes back to this idea of time and getting smart people who are motivated and dedicated to a vision, to work together and give them the time to be smart, to come up with good ideas and to develop them. And later on in the book, he writes a bit of a longer paragraph here, but it's a really good section that I think points out some common misconceptions around innovation and invention and how new products are developed. So the author says, we usually imagine that invention occurs in a flash, with a eureka moment that leads a lone inventor toward a startling epiphany. In truth, large leaps forward in technology rarely have a precise point of origin. At the start, forces that precede an invention merely begin to align, often imperceptibly, as a group of people and ideas converge, until over the course of months, or years, or decades, they gain clarity, momentum, and the help of additional ideas and actors. Luck seems to matter, and so does timing, for it tends to be the case that the right answers, the right people, the right place, perhaps all three, require serendipitous encounter with the right problem. And then sometimes a leap. Only in retrospect do such leaps look obvious. When Niels Bohr, along with Einstein, the world's greatest physicist, heard in 1938 that splitting a uranium atom could yield a tremendous burst of energy, he slapped his head and said, "Oh, what idiots we have all been." So again, here in this excerpt from the book, we see that time is such a huge factor in the development of new ideas and new products. We often look at inventions and innovations as he says in the book, large leaps forward in technology that kind of happen with a flash or a eureka moment. But that's rarely what actually happens. It's typically an idea a group of people have, they think about it, they test it, they develop it, they change it, and over the course of months, years, or sometimes decades, you gain slightly more clarity and momentum with more people, more ideas, developing this concept over time to eventually lead to, in some cases, an incredibly innovative product, sometimes an improvement that changes the whole landscape of a technological field. But it's only in retrospect, when you look back and see some big moment that appears to push this idea forward and be that eureka moment. But usually, once you dig into the details of it, there's actually a long list of ideas and people and tests and failures and overall time that it took to develop this new idea or this new innovation. Next, to develop good ideas, you also need collaboration. And what this means is smart, capable people who are motivated towards some sort of shared goal, and you have them co-located together. And these people need to have a willingness to work together and to push each other, and overall to put science and innovation and development above themselves. This means putting their egos aside, putting their individual career success to the side. Although, if you read this book, you will see there are plenty of people who played a huge role in the development of these technologies that definitely have egos, and it also leads to a lot of personal success. But in this co-located space, you need to have a willingness to help each other out, to push each other, to not hold too closely to your own ideas, because it's when you put it out there and actually let people provide feedback and their input on it that you can develop it a lot faster and also catch a lot of your blind spots and overall create a better technology. The other huge advantage of being co-located is that you really speed up the spread of information. There's not, nowadays, maybe this wasn't the case for the people working at Bell Labs back in the 40s, 50s, and 60s, but you didn't have to wait to send an email and then have someone look at their calendar, schedule a meeting, book a room. You can just walk up to the person or just lean back in your chair and ask them a question. So the speed of the spread of information is vastly increased by this co-location. And we will see in this book about Bell Labs that was one of the fundamental aspects and designs of Bell Laboratories, is they were trying to get all of these people who were experts in their own field co-located into a spot, into a laboratory where they would be forced essentially to communicate with each other, to walk by each other, to interact with each other's problems or tasks or whatever product they were working on. So in the book, the author says, they wanted the new building to reflect the lab's lofty status. And this is talking about the new laboratory building for Bell Laboratories. They wanted the new building to reflect the lab's lofty status and academic standing. Surroundings more suggestive of a university than a factory, in Buckley's words, but with a slight but significant difference. No attempt has been made to achieve the character of a university campus with its separate buildings, Buckley told Jewett. On the contrary, all buildings have been connected so as to avoid fixed geographical delineation between departments and to encourage free interchange and close contact among them. The physicists and chemists and mathematicians were not meant to avoid one another, in other words, and the research people were not meant to evade the development people. By intention, everyone would be in one another's way. Members of the technical staff would often have both laboratories and small offices, but these might be in different corridors, therefore making it necessary to walk between the two, and all but assuring a chance encounter or two with a colleague during the commute. By the same token, the long corridor for the wing that would house many of the physics researchers was intentionally made to be 700 feet in length. It was so long that to look down it from one end was to see the other end disappear at a vanishing point. Traveling its length without encountering a number of acquaintances, problems, diversions, and ideas would almost be impossible. Then again, that was the point. Walking down that impossibly long tiled corridor as scientists on his way to lunch in the Murray Hill cafeteria was like a magnet rolling past iron filings. So in this passage, we see that the Bell Labs was specifically designed to have people interact with each other. Your laboratory would be hundreds, if not thousands of feet away from your office, so that you were forced to walk past other people's offices, past other laboratories, run into people in this incredibly long hallway, spark up random conversations, figure out what problems they were having. Diversions and ideas were the point of the whole thing. You're supposed to get caught up talking to someone about some random idea they were thinking of or some random problem they had in their laboratory, which might be completely different. You could be a chemist that runs into a mathematician, or a physicist that runs into someone who's a development engineer. That was the point in the intentional design of the building. It wasn't about efficiency. It was about idea generation and product development. It was not so much to be able to produce a large quantity of products. This wasn't a production facility. It was an innovation facility. And I think that's one of the things that really separated Bell Labs from so many other companies at the time, is they had all these smart people and they didn't silo them. They kept them all together on purpose and essentially forced them to interact with each other. So this idea of collaboration is integral to being able to develop new, innovative, and creative ideas. The third lesson I took from this book and from studying Bell Laboratories on how to develop new and innovative ideas is the ability to ask good questions. So you need, first of all, the freedom to ask them. So you want to develop a culture that encourages people to speak up and to ask whatever's on their mind. And you need to develop this ability to ask good questions, which is a skill in and of itself. Good questions lead to a good hypothesis. A good hypothesis leads to good testing or good test design. And the better your test design, the better your results will be. So this allows you to in the end, develop theories, and these theories can lead to world-changing inventions. One example of this that is given in the book is a quote about a guy named Harry Nyquist. It says, "It wasn't the case that Nyquist gave them specific ideas. Rather, as one scientist recalled, he drew people out, got them thinking. More than anything, Nyquist asked good questions." This demonstrates the value that Bell Labs put on people who ask good questions, and it should tell us that you need someone like that in your development group, in your company. You need those people who are willing to ask the kind of questions that get the most out of other people, that get them thinking in new, in different ways, maybe asking questions that are difficult, the questions that perhaps will lead the company to realize they've been doing something wrong for a long time. And those are difficult questions to ask, especially if it means, you got to shift directions, which is a lot of money. It means losing a lot of money in the short term, but in the long term, the ability to generate a lot more money and be a lot more competitive and successful as a company. So you need those people who are willing to ask good questions, and you need to develop that skill in yourself, in the confidence to ask questions, no matter what context you're in. And finally, the last lesson is dedication. And this one probably seems obvious. Anytime you're trying to develop something new, create a successful company, everyone knows you need to be dedicated. But I think this point is, it was really reinforced and driven home again in this book and in this example of Bell Laboratories. There's so many stories of people working hard, working long hours, working very consistently, and having perseverance, specifically in the face of failure. They also loved the challenge. There's so many stories in here of people who they thrived off the challenge, off people telling them something was impossible or that it couldn't be done. It was too expensive. It was going to take too long to be able to achieve some outcome. And those are the things that really drove these geniuses who worked in the Bell Laboratories. They really relished this idea of the impossible. And to drive this point home even more, there's a really, really good quote from one of the, essentially the writer of this book is quoting one of the previous heads of Bell Laboratories. And this is what he says. "You get paid for the 7.5 hours a day you put in here," Kelly often told new Bell Labs employees in his speech to them on their first day. "But you get your raises and promotions on what you do in the other 16.5 hours. So the takeaway here is you get paid, obviously, for working your 7.5 to 8 hour days. That's doing the work that's required of you, that the company expects. But that's not enough to, especially in this context of Bell Labs, it's not enough to get you a raise. It's not enough to give you a promotion. Where the true success comes from is the work you put in the other 16.5 hours of the day, the time outside of work, or perhaps the time you put in working late. Because at Bell Labs, they knew you had to have dedicated people to actually develop these new products. Yes, there could be new ideas that came up with, but to actually drive a new idea and develop it into a piece of technology that was both innovative as well as manufacturable and something you could actually ship to customers, it takes a lot of time, a lot of dedication, a lot of hard work. So there's kind of this idea of these creative people who just sit around and think of ideas, and they have this natural innate ability to be creative. And there's some truth to that. There's definitely some natural abilities or natural tendencies towards creativity. But when you look at so many of these successful companies and products, there's always someone, whether that's Steve Jobs behind Apple, or in this case, this guy, Kelly, who was the leader of the Bell Labs, or he was the head of Bell Labs for a certain amount of time. There's someone driving people, pushing them to work harder, to be consistent, but also to work consistently long hours, to be honest. You have to put in that work. It's not going to get done by itself, and you're not going to be able to innovate without that drive. And when you look at things outside of product development, innovation technology, you look at sports, this is really what separates good athletes from the greatest of all time athletes. This is what separates players like LeBron James and Michael Jordan from all the other athletes. I mean, if you look at the NBA, there's a ton of 6'6", crazy athletic NBA basketball players, but none of them reach that level of, a very few percentage of them reach that level of Michael Jordan, Kobe Bryant, LeBron James. And so much of that has to do not with the amount of effort they put in while they're playing in the game, it's the amount of effort they put in outside of the game. It's going in to get your workout in before practice. It's eating all of the right food throughout the day. It's taking care of your body and going to your, whatever it would be, your training sessions with your team trainer multiple times a day while you're on the airplane. There's this story I heard about LeBron James, actually, and it was after he won not his first championship, but his first championship with the Cleveland Cavaliers in 2016. And the whole team, after winning, they fly to Las Vegas to have their after party. They're staying up late and, celebrating throughout the night. And a few of the players, I can't remember which players it was, it might have been Channing Frye and Richard Jefferson, were saying they slept in the next day. Obviously, they felt terrible. They were hungover, and they kind of hobbled out to the pool. And as they were walking out, they saw LeBron James walking out of the gym, dripping in sweat. And even that morning, the night after celebrating this championship, he was back in the gym, working out, and already had a sweat on at whatever it was, 7 or 8 in the morning. So that's what it takes. That's the kind of drive that it takes to actually lift yourself above all of the average. There's a lot of average people out there, and a lot of companies are full of average people. So if you want to go to the next step, if you want to innovate, you want to develop products that will change the world, you have to go to that next level. There has to be that dedication. And that's how a good idea is shaped. It's through this dedication that you put in the time to test and evolve and form a new invention or innovation into this world-changing product. Dedication really is the key to that. This is how good ideas were developed at one of the most prestigious and productive, quote-unquote, idea laboratories of all time. And I think we can learn so much from studying how successful people in successful companies worked and operated. And as a creative person or someone who's trying to be innovative and develop these new innovative products, I think you have to study Bell Labs. There's so many lessons and just little nuggets that you can learn from this company, from this factory of ideas. And so, I would highly recommend doing a bit of a deep dive yourself. So the Design30 discipline for this week is simply to go buy this book. It's called The Idea Factory, Bell Labs and the Great Age of American Innovation by John Gertner. There will be a link in the show notes to the book if you're interested. And just find a way to give yourself the time to develop these ideas, develop or create an environment where there's the ability to collaborate with your coworkers, practice asking good questions and not being afraid or intimidated to ask questions. And then finally, dedicate yourself to whatever it is you're doing and go all in on it. And that's all I have for this week. I hope you enjoyed some of the excerpts from this book, The Idea Factory, and I hope there's a few takeaways here that you can think about and try to integrate into your everyday work. And as always, you can find Design30 on YouTube, Instagram, and on Substack, on Twitter. So please like and follow. Please rate the podcast on whatever podcatcher you use, whether that's Spotify or Apple Podcasts. That would really help me out. And with that, I will bring this episode to a close. As always, remember, design more, despair less. Thanks for listening.